Hey guys, so in this video, we are going to go beyond basic AI chatbots and build something very interesting, an agentic application with real persistent memory powered by SingleStore. That's what we are building. And because, instead of an LLM that forgets everything as soon as the tab closes, we'll build a small personal mentor agent that actually remembers everything about you, like who you are, what you like, what are your goals, long term, short term goals across sessions. So this system basically tries to remember everything, and it retrieves and works as a proper agent memory. So think of it as an early version of a personal AI OS backed by a serious database that is single store. So we'll start from the basics. We'll try to understand what are AI agents, what are the components of an AI agent, and we will also see how the industry is moving from simple one-shot chains to fully agentic systems, right? Then we will zoom in on one critical piece that is often hand waved in many demos, that is memory. So, how do you maintain context? How do you store user profiles and goals? How do you retrieve the right memories at the right time for your AI agents or agentic applications? And that's where single store comes in handy as the agentic memory layer. So, by the end of this video, you will not only understand the concept, but you will have the complete working project with LangGraph, SingleStore, and Streamlit dashboard to visualize how basically your agent thinks and retrieves the chunks and the responses from persistent memory. Hey guys, so before we touch any demo part, let's basically understand what exactly is an AI agent, right? So at its simplest form, an AI agent is nothing but an LLM wrapper that can basically perceive, reason, and act. As simple as that. So instead of just answering a single prompt, it gets observations from the world like user messages, tool outputs, or API responses, then decides what to do next, right? Should I answer directly, call another tool, call API, function, store something in memory, or ask a clarifying question to the user, right? The key difference from a plain chatbot is autonomy and iteration. So basically, autonomy and iteration what make an AI agent very superior than just a chatbot, right? The agent can take multiple steps, keep track of an internal state, and use tools to achieve a goal. And that's what the AI agent, the capabilities are. So in our tutorial, the agent is a personal mentor that talks to the user, decides which facts are worth remembering, and writes them into single store as a long-term memory, basically. And in our tutorial, we're going to use LangGraph as the orchestration layer. So we can model the agent as a small state machine. And we can retrieve memories, call the model, optionally called tools, and loop until we are done. So um, keep this mental model in mind, and the agent is not the LLM alone, it's the LLM plus tools plus memory and control flow. So today we're going to see that everything in a nutshell through a simple project, I mean the tutorial that I have at the end. Okay guys, so we understood what is an AI agent, what are the different components of an AI agent, and how does an AI agent basically work. But have you ever thought how and from where these AI agents get their memory from, how they store the memory? Not just store, how they remember the conversations and whole chat history, right? So, our agentic systems should not be like just a short term remembering systems, right? They should know the context, and when you ask a question again, they should remember what happened previously, and there should be context of what all happened. So there should be a chat history, and that chat history should be stored somewhere for these AI agents. And that is where we talk about something called agentic memory. And most of us know that the year 2026 will be all about agentic memory. And that is where we try to use a very robust database, not just a vector database, but a robust database that doesn't just store data, but stores it in an organized way to help our agentic system retrieve the contextually relevant and accurate responses whenever query is being asked, right? So in this tutorial today, we are going to use single store as our agentic memory layer. I'm going to show you that whole setup and the tutorial in a minute or so. But But I also wanted to show you or share with you that recently, folks from Vectorize have created a agentic memory layer tool or a platform called Hindsight, which is amazing. I'm also going to show you that also how that works. But let's first see how SingleStore handles the agentic memory part. Right? Hey guys, so this workflow represents the agentic memory loop we are building today in our tutorial. The user interacts with an AI agent which receives messages and reasons about what to do next. Before responding, the agent retrieves relevant memories such as user profile, details, goals, and preferences from long term memory. In our implementation, this memory is stored persistently in single store, enriched with metadata like importance and timestamps. The agent uses these retrieved memories to basically personalize its reasoning and responses. So, when the agent detects new stable information, it writes new memories back to single store database, closing the loop. So this continuous read, reason, write cycle is what turns a simple AI agent into stateful adaptive agentic system. So let's see how this works practically. Hey guys, so we saw what exactly is an AI agent, the components, and the different layers that our tutorial has, the different files, right? So let's directly now go to our tutorial and see um how exactly the agentic memory tutorial basically works. So let's go to the VS Code. Hope you can see my screen. And yeah, we have a .env file that contains the credentials, the OpenAI API key, and our single store URL. And we have db.py that holds the database logic for single store. As you can see, it has single store URL, and the same thing is also there in our .env file. And there is also, it is creating some tables inside our database, right? So the database, inside the database, it is creating a table named agentic memory, and that is where we are keeping all the chat history and all the conversation for further usage. And graph.py is because we are using LangGraph. LangGraph, as you know, it's a framework by LangChain to help you build dynamic, stateful agentic workflows. So that's why we are using LangGraph, and graph.py contains all the uh, agentic graph, the tools, and all the logic that LangGraph basically has. And we have main dot py, which contains the main logic of the application. What should happen? So it basically asks you a question. I mean, like, you can chat with this chatbot basically, with this AI agent, and whatever you say, it will go and add that as a memory into the database. So once I run main dot python main dot py, you will see, we'll see in a while. It basically gives me thing to, hey, as you can see, let me show you that. So if I run python main.py, so it will ask me, I think, let's see what happens. As you can see, I can say, hey, I recently visited visited Mumbai. Can just say that, and it'll basically, it's like a, it'll take that as a chat history, and it'll store that into our database, right? It says, the agent will say, that's great, how was your visit to Mumbai? Did you get a chance to explore any particular places or try some local cuisine? So I can just chat with it. So and memory store py is like how the memory gets stored into our database. with all the metadata, all the user ID, memory type, importance, source. It gives all these scores by itself, right? And it will segregate everything properly. And requirements.txt is all the Python dependencies we need to have. And we have Streamlit app.py, which basically the UI, right? I'll show you how that basically looks. So if we go to this and then run this, and this is where you will see the dashboard. So this is our dashboard, Agentic Memory dashboard. So as you can see, what do you know about me? What do you know about the user, as if it's about me? So I have already chatted with my AI agent a lot of times already. So there is a top K. It'll retrieve the top K uh, from the chat history, and I'll set it to 3, and also minimum importance. 5 is more and 1 is minimum. And I can say, like, if I just run memory search for what do you know about me, it'll just search with the hybrid semantic with all the importance, right? As you can see, we found 3 memories because I have kept it like top 3. And you can see episode importance, profile importance, and memory type is episode. Users recently visited Paris and loved it. Yeah, I have chatted with my AI agent, like I said before also. Score is 0.3, 0.37, 0.32. So this is about the profile. Username is Power, and they are a Gen AI evangelist. And again, the importance is 4. The score is 0.3292. And similarity is zero point 0.1. User's YouTube channel name is Pawan Belagati. The videos are useful for AI, ML, and data engineers. So that's what the agent knows about me. That's about me. And I can ask, like, what else user likes or loves to do, right? So let's keep top 3, 3, and then minimum importance 1. And I can also choose what type of from the memory type, if I want a profile, preference, goal, episode, but will not will not like select anything. I will keep it optional and run this. Like, what else I like? I have already, like I said, I have already chatted with my agent. So we got the found 3 memories. And so, as you can see, episode, preference, and the content is user recently visited Paris and loved it. User loves exploring different cuisines around the globe. User loves building agentic applications. Right. So as you can also see, the score, similarity score, semantic score, and also the importance. So, like I said, .env basically holds your credentials. The OpenAI API key is what we need. Add your OpenAI API key and single store URL. So this is how it goes. Um, uh, MySQL, by MySQL, username, password, host, and port is common. And agentic memory is our database name. So once you go to single store, can go to single store, sign up and sign in. Single store has a free share tier, and this is where you will land. So you need to have a workspace. If you don't have a workspace, create one, and it's very easy to create. And then attach to your workspace, create a database. So I have already created my database. The database name is Agentic Memory, and that's what you're seeing here, Agentic Memory as the database name, right? And yeah, like, I also discussed what each of these files do. And now I ran my application python main.py, and I'm just chatting with my agent, like, I recently visited Bangalore. It said, like, that's great. How was your visit to Bangalore? Did you explore any interesting places, try any cuisines there? And I said I ate idli and vada and also dosa. So I've been chatting with my agent, agentic application, and then I also ran this. Let me cancel and run again, so that you can see this is how the dashboard basically looked. And I can say, I can ask, like, which place um, the user visited recently. If I say, if I keep it to, I don't want to get maybe 2, run search. run memory search, and it will go and run the hybrid search, and it will be like user recently visited Bangalore. Like I said, right, I recently visited Bangalore is what I said to my AI agent. And user recently visited Paris and loved it. Yeah, I also said that before previously. And you can see the same thing in our database. Let's go to database, and let's go to the database name is Agentic Memory, and memories is the table name that we have created. And if you go to sample data, you can see the embeddings created for our content. Right, this is the content that is stored, and this is the memory type, preference, goal, profile, and user ID. It is taking it as user. You can change that. The type is chat. I'm chatting with the agentic application, and when it is created, and you can see user loves exploring, user loves bike riding, and he visited Bangalore recently, right? So I can also, so this is how the data has been stored in a very organized way, with all the importance score, the source, the session ID, and the content, and it's also creating an embedding, right, of that content and when it is created. So I can also go and talk more like what else. What is the goal of the user? If I say, what is the goal of the user? Is there anything that he wants to do? So, yeah, we got users' long term goal is to build a successful AI education company. User loves building agentic applications, so that is the that's how it is getting some semantic similarity score here, and also doing a hybrid search along with that, and it is giving the memory type also with the importance, right, and it is giving us the retrieving the proper contextually relevant responses, as we see here. And that's how you can ask different things, and you can also go to user profile view. It'll give you the whole view how it looks. So refresh, click refresh. So yeah, this is how it looks. Let me refresh this. Go here, and if I say refresh, I should wait for some time. Yeah, profile, under profile, user's name is Pawan and they are a Gen evangelist. The score, and when it is created, and user's YouTube channel name is Pawan Balagati. Users has a YouTube channel, and goals, preferences. What are his preferences? So it is. This is how everything is stored properly. And raw memory table, right? Load table. If I say load table, this is how it is getting loaded, and I can also see, right, everything here, content. This is getting it from our database, and this is admin hygiene. I can delete memory, I can wipe all the memory from there. And yeah, I mean, this is how you can basically build agentic memory, a dashboard, or agentic applications, and then use single store or any database for that matter as a agentic memory. Why single store? Because it supports all types of data, and it can also be used as a vector database. And since we're also using LangGraph along with single store, so this is uh, this is a proper mix of a tutorial to show you how agentic memory basically works. Hey guys, so folks at Vectorize have come up with an agentic layer or agentic memory layer, or a tool or a platform that you can call. It's called Hindsight, as you can see. And instead of using a dedicated database, this memory layer will help you, while building agentic AI applications. And if you can go to vectorize.io and you can read more about it. As you can see, right, agents that remember, agents that learn. And they say introducing Hindsight, a new approach to agent memory, best in the world on benchmarks, best in production for your agents. So you can try it on GitHub. You can go to GitHub, or you can also go to their um, uh, or you can say the docs, right? And you can also try Hindsight Cloud. You can get the early access, but let's go to the docs, right? They have given all the architecture, your application, the Hindsight, the documents, the memories and entities, how the everything is stored. And it also says like your AI agent stores information via retain, recall, and reflect. These are the three things you can use to interact with your AI agent. And let's start from the start, right? Why Hindsight? AI agents forget everything between sessions. Every conversation starts from zero, no context about who you are, what you have discussed, or what the assistant has learned. This isn't just an implementation detail, it fundamentally limits what AI agents can do. So, vector search is not enough. You need to have a proper layer that just holds everything contextually relevant, stores it in a safe place, and that's where Hindsight comes into the picture with all the three memory types: word, bank, and opinion. And all the structure is given here, right? The getting started, there is a getting started, and these are the three core components. Retain, how memories are stored with multi-dimensional facts. Recall is how Tempere's four-way search retrieves memories, and reflect is how disposition influences reasoning, and opinion formation opinion formation. And these are the API methods. So you can directly go to the quick start and then start with this pip install Hindsight and export a OpenAI API key, share your OpenAI API key, and then um, I have already started this. And as you can see, this is my simple application. I have in .env file. I have the Hindsight base URL. That's where the application starts, and then bank ID, my bank V2, and then agent PY holds all the logic of our agent. And as you can see, the memory agent, retain, recall, reflect, the three components: stores, retrieves, and the these produce a disposition aware response using recall context. And yeah, everything is present in agent.py, all the logic. And this runs the backend of the application. And run.py again is where our base URL is. And then uh, these are the different things you can talk to, and then that's how the memory is retained, right? So let's run. I ran this application, as you can see. So once you run it, it says like the URL is here. This is the database. Then the LLM used is GPT-5 Mini. Embeddings local, local transformer, local again. Re-ranker is also local, and then MCP enabled. And it says the application has started. The If you go to metrics, and if you open this port and go to metrics, you can basically see the metrics metrics part of it. And then if you go to the docs, this is where you will see the Hindsight HTTP API. And yeah, I just ran this, and it said memory system initialized. And now we can actually start, or in another terminal we can start with python run.py. So I ran it, and I asked like, you once you start this, it says Hindsight memory agent demo, and then you can ask things like recall, what does Alice do. These are the recall results. Alice works at Google as a software engineer. Her role is a software engineer employed by Google, performing engineering duties for the company. And again, it gives you all the things that is related to Alice. And also, if you go to uh, like uh, world, where does Alice work? Like Alice works at Google as a software engineer. Role is, yeah, I mean, anything related to her. And then reflect. If I use reflect, would Alice be a good fit for an ML heavy project? It says, I think. Agent comes and says, like, I think Alice looks promising for an ML heavy project, but I wouldn't hire her on that alone without targeted validation. I am optimistic. TensorFlow specialization, Google SE background. So it gives all the context about her, why you should hire or why you should not hire, all the validations, proof, and it also gives you a bottom line. Like I believe Alice is likely a strong candidate for TensorFlow heavy model development and blah blah blah. And also say reflect what should you keep in mind when helping me with code. Say the agent will come and say, I think about a few concrete things when helping you with code, so my answers actually match how you like or work and what you will do with the result. What I keep front and center, so it will give you some answer, like what it believes in when giving you the code. And recall who is connected to TensorFlow. Allies specialize in TensorFlow, blah, 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 blah. So that's where you can actually talk to your agent and it will give you how everything that is related to, right? Recall, reflect, and all those things. So that's how instead of using a proper mm, database like we saw before, you can also use Hindsight and whenever you are building agentic applications.